Hello, my dear boys. Good morning. I hope all of you are well. Uh, Today we will discuss another type of mathematical problem on current electricity. This is our final class on current electricity. Try to try at home more mathematics on this chapter because this chapter is very important for our board examination. Okay, then you can see that our another type of problem, and the problem is this is a given circuit. This is a given circuit, and that is our stem. In our stem we can see that here we have three resistances. Number one resistance is 12 ohm. This resistance is 12 ohm. This resistance is 66 ohm, and this resistance is also 12 ohm. And we have one electromotive force, and that is the value of EMF is 12 volt. And we also have two switch 1 and switch 2. Okay, in this type of math we will discuss how switch is working in our circuit. Okay, now this is our question now C is, if S1 and S2 is closed, if S1 and S2 is closed, okay, what will be the total resistance of the circuit? Okay, I'm repeating again. If S1 and in this system we can see that S1 and S2 are in open. Okay, if the S1 and S2 is open, then there is no current flow through the circuit. Okay, then our question is, if S1 and S2 is closed, what will be the total resistance of the circuit? Okay, now question number D is, if S1 is switched off, here switched off means close, and here switched off means the current will flow through the wire. Okay, here again I am repeating, if S1 is switched off, S1 is switched off, S1 is switched off, compare the power spent when either S2 is switched off or switched on. The math says that if S1 is closed for these two conditions, and one condition S1 is open and another condition S1 is closed, then we have to compare the power for both conditions. Okay, next I am okay, we are going to solution doing solution of this problem. Okay, now for the solution of C, we first of all we have to do name of these resistances. We know that the current is passing through the positive side of the EMF. So current will passing through this side. So this resistance, we can name this resistance as R1. We can name this resistance as R2, and we can name this resistance as R3. Okay. Then in our first question of C, our condition was, if switch S1 and S2 is closed, then what will be the equivalent resistance or total resistance of the given circuit? Now we need to moderate our figure or our circuit as our condition or as our question. In our question, the S1 and S2, according to our question, S1 and S2 must be closed. So we can here switch S1 is closed and also switch S2 is closed. Okay. Switch S1 is closed, so current will flow through the resistance R1 and resistance R2 as well as resistance R3. Okay. Now we can see that the current is divided. Into two parts from our switch 2. Then the resistance R1. So we can say that according to our parallel circuit, we see that the resistance R1 and resistance R2 is in parallel. So we can write resistance R1 and R2 are in parallel. So in our first part, the equivalent resistance will be 1 by RP1. RP1 equal to 1 by R1 plus 1 by R2. Again, we can write R1, the resistance R1 is 6 ohm and the resistance R2 is 12 ohm. So we can write R1 resistance as 6 plus 1 by R2 as 12 ohm. Get LCM. The LCM will be 12. So we can write 2 plus 1. 1 by RP1. Again we can write 1 by RP1 as 3 by 12. So we can write dividing we can write RP1 as 4 ohm. Okay. Now we can moderate this circuit as by the resistance R1 and R2 we get the first equivalent as RP1 and we can put in our figure as RP1 for this resistance. RP1 equal to 4 ohm. Again we see that in RP1 resistance and R3 resistance the same current is passing. So according to the definition of series combination, we can say that RP1 and R3 are in series. So our final equivalent resistance will be RP1 and R3 are in series. So the final resistance will be R equivalent equal to R3 plus RP1. So we can write 12 plus RP1 as 4. So 16 ohm. In our given stem, the final equivalent resistance will be 16 ohm. So we can write that if S1 and S2 is closed, closed, then 16 ohm resistance, 16 ohm resistance, then the total resistance will be 16 ohm. Okay, this is our final answer for question number C. Okay, then we will go to our question number D. I am erasing the solution of question number C. To solve the question number D, we need to draw the figure again. So I am drawing the figure again. This is our given state. Now, in question D, we have if S1 is closed. This is S1, this is S2. If S1 is closed or switched off, compare the power spent when either S2 is switched off or switched on. For both condition, we can see that our first condition is S1 is closed. Then S1 is closed. We can see that if S1 is closed, our first condition, S1 is closed and S2 is open. If S2 is open, no current will passes through R1 resistance. Okay, no current will passing through R1 resistance or 6 ohm resistance. Okay, then the current will passing through resistance R2 and R3. So, and we can again see that the same current is passing through R2 and R3. The same current is passing through R2 and R3. Okay, then we can say that R2 and R3 is in series. So, the RS1 is R2 plus R3, and we can write that R2 as 12 plus 12, and the total equivalent resistance for our first condition is 24 ohm. Okay, for our first condition we need to determine the power of the circuit. We know that the formula for power of the circuit is P equal to VI. So first of all, we need to determine the current for first condition. For first condition, we see that our equivalent resistance is RS1 because S2 is open, so no current passing through R1. So we can write I1 equal to E by RS. So we can write 12 by 24. Here can write 0.5 ampere. Ampere is the unit for current flow. Okay. Uh, we get our current flow passing through R1 and R2 resistance, and that is 0.5 ampere. Now we can determine the power of the circuit. The power of the circuit, for first condition, the power of the circuit is P1 equal to VI1. Here V is equal to E, because in our electromotive force there is no internal resistance. If there is no internal resistance, then the total electromotive force will be our total voltage or potential difference. I am telling again, if there is no internal resistance, then total EMF or electromotive force will be our total potential difference or voltage. So we can write V as E as V. So we can write 12 into I1 as 0.5. So our result will be 6 watt. So we can see that for our first condition the power is 6 watt. The power is 6 watt. Now for our second condition. For our second condition, we are going to our second condition. I'm writing here our first power P 6 watt for our future use. Now for second condition, what is our second condition? S1 and S2 both are closed or off. Then our figure will be like that, S2. And we say that the figure is looking like as our question number C, question number C. The figure looks like as our question number C. Okay. Then we get our total equivalent resistance from question number C. Total equivalent resistance Req equal to 16 ohm. We can write here from C. Okay. Now the current flow for this circuit is I2 as E by R equivalent, and E is 12 ohm and R equivalent is 16 ohm. Then we can write as 3 by 4 as 0.75 amperes. Now the power for second condition is power for second condition is P2 equal to VI2. Then our V is our V is 12 and I is 0.75. So we see that our power for second condition is 9 watt. We can see that from here our power for first condition was P1 equal to 6 watt. Okay, P1, I'm writing here again, P1 equal to 6 watt. Then the comparison, comparing, so P1 divided by P2 equal to 6 by 9. So we can write 2 by 3. So we get that P2 is greater than P1. So we can say that in our question, or in our comparing between these two conditions, we can say that the power of second condition, or the power for when the switch S1 and S2 is closed is very much greater than the power for our first condition, as when S1 is closed and S2 is open. Okay, you need to write these letters, or this explanation after solving this math. Okay, so this is our last class for current electricity. In our next class we will discuss about our chapter 12, and the name of chapter 12 is magnetic effects of current. We will discuss in our next class on magnetic effects on current. Until then, thank you.